All right, here's example number 5b. Hopefully you paused the video after doing example 5a and you tried this one on your own, kind of comparing it with the example that we just did. Hopefully you picked out the important characteristics of this graph. I found a hole at x equals -2. I found a vertical asymptote at x equals +2. And it looks like there is a horizontal asymptote. It looks like, again, at y equals 1. Where does it touch the x-axis? It looks like there's an x-intercept at 3-ish, at x equals 3. And it looks like there's a y-intercept between 1 and 2. So can I say 3/2 or 1.5? Right? We can just use these again as guides and hope that it kind of matches as we start to plug in our values. With those in mind, can we start making our function? Well, if I know that there is a hole at x equals -2, there should be a factor on the top and the bottom of x plus 2. If I know there's a vertical asymptote at x equals +2, then I know there's a factor on the denominator of x minus 2. And if there is a horizontal asymptote at y equals 1, my degree of my top, my degree of my bottom should be equal. So if my denominator is going to work out to be an x squared, my numerator needs to also be an x squared with leading coefficients that divide into 1. So I should have another x, possibly a value added or subtracted to it at the top, so that if I FOILed it, I'd have that 1x squared as my leading term. Now we also have to consider our x-intercepts, our y-intercepts. Remember our x-intercept was 3. So when x is 3, y is 0. So I should be able to use my numerator, because when the fraction equals 0, that means the top equals 0, right? So I can set y equal to 0 and x equal to 3. Find that missing value at the top by solving that equation. I divided 5 by both sides. I subtract 3, and that missing value to me looks like it should be a -3. All right, if that is a -3, and I know my y-intercept is around 1.5, can I plug in 0 for x, my -3 for that missing value that I found, and actually find my y-intercept and hope that it matches around 1.5? I end up simplifying to a 2 times -3 on the top, that's -6. On the bottom, I have a 2 times -2, which is a -4. So I ended up with a y-intercept of 3/2, which is actually perfect, right? Isn't that what we estimated it to be, between 1 and 2? So my final function factored version would be an x plus 2 times x minus 3 on the top, on the numerator, and an x plus 2, x minus 2 on my denominator. A FOILed out version would be an x squared minus 1x minus 6 on the top over x squared minus 4 on the bottom. Hopefully you were able to get the same thing, and you can now work forward and backward. If I give you an equation, you can graph it with all the important characteristics. Or if I give you a graph, can you pick out all the important characteristics and give me the function?